I welcome you all in this lecture. In this lecture, we will solve one problem from previous gate, which is based on machine design. Now let us read the problem. Bars of square and circular cross section with 0.5 meter length are made up of material with a shear strength of 20 megapascal. The square bar cross section dimensions are 4 cm by 4 cm and the cylindrical bar cross section diameter is 4 cm. The specimens are loaded as shown in figure. So in this figure you can see the specimens are loaded. So first is for tensile load. Specimen with square cross section is subjected to tensile load of 80 kN. Then the second specimen with compressive load is subjected to compressive load of 80 kN. Next is the circular cross section specimen, which is subjected to torque of 64 pi Newton meter. And the last is the square cross section specimen, which is subjected to bending moment of 320 Newton meter. So these are the four specimens: tensile load, compressive load, torsional load and bending load are the loads in corresponding specimens. And it is asked in the next line, which specimen or specimens will fail due to applied load as per maximum shear stress theory. And these are the options: torsional load specimen, bending load specimen, C, tensile and compressive load specimens, and D, none of the above. Okay, so these are the options. So first of all, write the given data in short. So first, the length is given, it is 0.5 meter. So in mm it will be 500 mm. Next, the material strength is given, that is shear strength. So shear strength is given, and it is denoted by tau, which is equal to 20 megapascal. Next, the square bar cross section size is given. So for specimen with square cross section, the size is 4 cm by 4 cm, and in mm you can write 4 mm, 40 mm by 40 mm. And for cylindrical cross section specimen, the diameter is 4 cm, and in mm we can write as a 40 mm. Then the loading is given for these specimens, its magnitude is given, and we have to find out which specimen will fail as per maximum shear stress theory. So remember that here, very important point, as per maximum shear stress theory, failure occurs when induced shear stress becomes greater than shear strength. That means first of all we have to find out the induced stress in all these four specimens, and when you find the induced shear stress in any one of the specimen is greater than the shear strength, then we can say that that specimen will fail. So let us find out the stresses in each specimen one by one. So consider the first specimen. So specimen with tensile load. So it is subjected to tensile load of magnitude 80 kN. So tensile stress will induce, and it can be calculated as P upon A. So P is 80 into 10 raised to 3 Newton upon area. Area of this square cross section can be calculated from this dimension. So 40 mm into 40 mm. So if you calculate, you will get the answer as 50 megapascal. Now, in order to predict the failure of this specimen which is subjected to tensile load, we have to find out the maximum shear stress induced in the specimen, and maximum shear stress tau max can be obtained using this formula, sigma T upon 2. So maximum shear stress in this case is half of the induced tensile stress, and thus we can write 50 upon 2 is equal to 25 megapascal. So this is the magnitude of induced maximum shear stress, and this induced shear stress magnitude is 25 and shear strength is 20 megapascal. So that means we can say that this induced tau max is greater than shear strength 20 megapascal. Therefore, this specimen will fail. Okay. Now similarly go for the second specimen. Specimen with compressive load. So stress will induce compressive stress. P upon area is the formula. So P is again 80 into 10 raised to 3 Newton, and area for square cross section is 40 into 40. So same answer you will get as that of sigma T. So answer of sigma C is 50 megapascal. Let us calculate induced shear stress, that is tau max, maximum shear stress, and it is half of this induced compressive stress. So we will get maximum shear stress in this specimen as 25 megapascal. Now if you compare this value of induced compressive stress with the shear strength, if you compare the value of maximum shear stress in this specimen with the shear strength, you can find that this value is greater than shear strength. This value is greater than shear strength, which is having magnitude of 20 megapascal, and therefore this specimen will also fail. Okay. Now let us go for the third specimen. Now for the third specimen we have circular cross section specimen, and which is subjected to torsional load, and torque magnitude is 64 pi Newton meter. So let us find out the specimen. So here the specimen with torsional load is subjected to torsional shear stress, which is given by formula mt upon j into r. So mt value, that is torque value, is given 64 pi Newton meter. So convert it into Newton mm. So multiply by 10 raised to 3. J is pi by 32 d raised to 4, and r is d by 2. Here diameter of this specimen is given 4 centimeter, that is 40 mm. So let us put these values. So therefore 64 pi into 10 raised to 3 upon pi by 32 40 raised to 4 into 40 upon 2. If you calculate this value of this induced shear stress in this specimen, its magnitude is 16 megapascal, and this 16 megapascal, it is the value of induced shear stress, and it is less than shear strength value of this material, that is less than 20 megapascal. Therefore this specimen will not fail. This specimen will not fail under torsional load. Okay, as the induced shear stress is less than shear strength, that is 20 megapascal. Now similarly, now check the fourth specimen. Now the last specimen is specimen with bending load, and the bending moment is given, its magnitude is mb is equal to 320 Newton meter, and the formula for bending stress is sigma b is equal to mb upon I into y. So as this specimen has a square cross section, so I, that is moment of inertia, will be bd cube upon 12, and y will be d upon 2. So as b and d are same, so therefore write mb value. So it is 320 Newton meters, convert it into Newton mm. So multiply by 10 raised to 3 upon I is bd cube upon 12. So b is 40, that is this, both the dimensions are 40 mm. So bd cube, d is also 40 upon 12 into y. Y is again distance from neutral axis, so it is half of this d, and it is 40 upon 2. So if you cancel out and if you simplify this, you will get the answer of this bending stress, and the value of bending stress is 30 megapascal. Okay, but here in order to predict the failure, we cannot compare this value of bending stress with the shear strength, because we have to use the maximum shear stress theory. So we have to first find out the induced maximum shear stress in this specimen, and induced maximum shear stress tau max is half of this sigma b, and thus we can write tau max is 15 megapascal. Now if you compare this value of maximum shear stress, maximum induced shear stress with the shear strength of this material, we can find that this induced maximum shear stress is less than shear strength. So 15 megapascal is less than in shear strength of 20 megapascal, and therefore this specimen will not fail. Okay, so from this solution we found that the specimen with the tensile load, it will fail, and the specimen with compressive load will fail. So therefore the correct option for this problem is C, that is the specimen with tensile and compressive load will fail.